Hello, this is Dr. Morgan. Today I want to go over with you the Math 7 Semester 1 Practice Final. I want to remind you that this practice final is exactly like the semester final that you will be taking, only the numbers have been changed. So make sure what you want to do is not just know how to do this problem, but if you will learn how to do the problem, when you get on the final, the numbers will be different, but if you know how to do the problem, you won't have any trouble with the final. So let's begin. Get started. Problem number 1. 4 expressions are shown below. Expression A, negative 3.72 plus 1 and 2800ths. Negative expression B, negative 3 and 7200ths minus 1 and 2800ths. And then C, negative 3 and 7200ths plus a negative 1 and 2800ths. And finally D, negative 3 and 7200ths minus a negative 1 and 2 and 2800ths. Which expression would give the same answer? Select all that apply. If you don't see this right away, we can always just add each of them and get an answer. So I'm going to use a T-chart, and remember that in a T-chart we put the positive on one side and the negative on the others to begin with. So in our first expression A, we start with a negative 3.72, so we'll put the negative 1 on the right side, and then we're adding a positive 1.28, so we put that on the other side. Now in the T-chart, we take the smaller number and subtract it from the larger number. So we bring this over here and we subtract it, and the expression would be 2.24 in the negative side. So in this case, we have a negative 2 and 4400ths. So let's take a look at B. In B, remember that subtracting a number like 5 minus 3 is the same as adding the opposite, 5 plus minus 3. So we're going to change subtracting 1.28 into adding a negative 1.28. So this becomes negative 3 and 7200ths plus a minus 1.28. So now when we do our T-chart, we have a 3.72 on the negative side and 1.28. When we add those together, it comes out to 5, and again that's on the negative side, so the answer is 5. These two obviously are not the same. Let's try number C. C, we have negative 3.72 and we have a negative 1.28. Notice that this is going to end up to be exactly what we had, so we know now that B and C are the same. Let's try D to finish our problem out. Notice again on D we have subtracting a negative, so we'll change that into adding the opposite. So subtracting a minus becomes adding a positive. So in this case, in our T-chart we have the negative 3.72, but now we're going to add 1.28, take the smaller number and subtract it, and notice we end up with the same as A. So A and D are the same. So let's look at our answers then, and we notice that A and D are the same. In the following problem, it says that an action figure is 6 inches tall. If the toy company modeled the action figure off of a TV star who is 6 foot 6 inches tall, what ratio did they use? So let's begin by setting up the ratio, comparing the TV actor to the model. And we notice that the TV actor is 6 foot 6 inches, and we're going to put that over 6 inches. Now, because we want a real ratio, we need to have them in the same unit. So the next thing we'll do is convert the feet to inches. 1 foot equals 12 inches. So I'm going to take my 6 feet and multiply it by 12 inches. Then I still have an additional 6 inches to add to it. So 6 times 12 is 72. Add the 6 inches and we have 78 to 6 as our ratio. Now we should simplify the ratio, and we notice that we can take a 6 out of both of these. So 78 divided by 6 is 13. 6 divided by 6 is 1. So the ratio here is 13 to 1, and that's our answer. In problem 3, we're asked to evaluate the expression 16 over 24 minus the quantity 1/4 plus 1/6. In order to do this problem, when we're dealing with adding and subtracting fractions, we need to write them both with common denominators. So in this case, between 24, I'm looking at 4 and 6 and 24. I look at the multiples of them to find what number they're all the common denominator. and I notice 24. 4 goes into 24, 6 goes into 24, and obviously 24. So we need to change each of these so that they have the same denominator, 24. The 16 is okay, and you notice we're going to end up having to multiply 1/4 by 6 over 6. And as you look at this answer, you'll see that by doing this, the 6 times 4 is going to give me the 24. And likewise over here, 6 times 4, 24. But in order that we don't change the number, this number here, 6 divided by 6 is 1. Likewise, 4 divided by 4 is 1. When you multiply by an expression of 1, you're not actually changing the value here. So now let's do the multiplication. And we have 16 over 24 minus 6 over 24 plus 4 over 24. Now to continue, we're going to follow the PEMDAS rule, and we'll add the fractions first before we subtract. So 6 plus 4 is 10 over 24, and now we can subtract, and we get an answer of 16 minus 10 is 6 over 24. So let's simplify this fraction, and they both can be divided by 6, and we divide both by 6, and our answer is 1 over 4, and that's our answer, 1/4. Our next problem asks us, what is the sum of negative 47 and 8? I'm going to show you 3 different ways to work this problem, whichever way you're most comfortable with. The first way is to use the addition rule. You may remember this as a song. Same signs add and keep, different signs subtract. Take the sign of the higher number, then you'll be exact. So this is different signs, minus and plus, so it says different signs subtract. So 47 minus 8 is 39. Now finally, I just need to figure out if it's going to be positive or negative. Take the sign of the higher number. Well, the higher number is 47 and it was negative, so my answer is negative 39. That's one way to do it if you understand that rule. Another way that always works is to look at your number line. So I find negative 47 and then I add 8. 1, 2, 3, 4, 5, 6, 7, 8, and my answer again is negative 39. A third way to add two numbers is the T-chart. So in the T-chart, I start with negative 47, so I put 47 in the negative column, positive 8, 8 goes in the positive column, take the smaller number and subtract it from the larger number, and we get 39 in the negative column, so the answer is negative 39. So whether you do it by the rule or by the number line or the T-chart, we get the same answer, negative 39. In problem 6, it gives us a recipe for cookies and shows the following ingredients. And now it wants us to tell us which of the answers shows the correct amount if Eric wishes to triple the recipe. Well, triple means 3 times. So what we need to do is take each of these and multiply them by 3 and see if they match our answers. So first look at the flour. Flour, 3 times 2.5. So the first thing I do is change the mixed number to an improper fraction. If you remember that, 2 times 2 is 4, plus 1, 5 halves. Now we can multiply across. 3 times 5 is 15, 1 times 2. And so the answer there, if we go back to a mixed number, 2 goes into 15 7 times with 1 left over. So the answer is 7.5. And you'll notice in the answer A says 6.5. So A is not a correct answer. So let's look at chocolate chips. Chocolate chips, 3 times 2/3. So that's the same as 3 over 1 times 2/3. And now we multiply across 6 over 3, or 2 cups of chocolate. Again, we look at the answer B, and answer B is 6 over 9, which is not 2. So B is not an answer. Look at the chopped almonds next. 3 times 3/3. Again, make that 3 over 1 times 3/3. Multiply the numerators, 9. The denominators are 5. 5 goes into 9 one time with 4 left over, so 1 4/5 or 9/5. Notice the answer is 9/5. So this one would be a correct amount of almonds if we triple it. So C is a possible answer, is one answer. Next we have the brown sugar. 3 times 2 1/3. let's change the mixed number 2 1/3 to an improper fraction. So once again, we're going to go 3 times 2 is 6, plus 1 is 7. So we end up with 3 over 1 times 7 over 3. Multiply the numerators. 3 times 1 is 21. Multiply the denominators. 1 times 3 is 3. And 21 divided by 3 is 7. So we would end up with 7 cups of brown sugar. And notice here it's still 2 1/3. So that would be incorrect for our triple. Let's go next to the white sugar. 3 times 5/8. So change the 3 to 3 over 1. Multiply the numerators. 3 times 5 is 15. 1 times 8 is 8. 8 goes into 15 one time with 7 left over, so 1 7/8. Look at our answer E, and that is the same answer, 1 7/8 cups of white sugar. So E is the result we would have if we tripled the recipe. And finally, salt. 3 times 1/3. So change 3 to 3 over 1. Multiply the top. 3 times 1 is 3. The bottom, 1 times 3 is 3. That's obviously 1. The answer says 1/9 of a teaspoon, and that is obviously not the same. And so F is also an answer. So our answer here would be C and E. Number 6 asks us which of the following fractions are less than or equal to 0.34. Well, the way to handle this the easiest is to change each fraction into a division problem. For example, 4 divided by 11 means 4 divided by 11, or 11 into 4. And if you use your calculator and simply divide 4 by 11, or you do it longhand, you discover that 4 over 11 is 0.36 repeated, which is 0.36363636. And you can recognize that 3/6 is bigger than 3/4, so this is not less than, so A is not a possible answer. For B, 1/3, again, we would take 1 and divide it by 3, and if you use your calculator or longhand, you find that that's 0.33333. Well, 3333 is less than 3/4. You can line them up. Remember, if you want to see if they're different, just line them up on top of each other. 0.34 and 0.33. You can see they're the same here, but here, this one's larger. That's why I know that's larger than the other one. So in this case, this would be a possible answer. C, take 10, the numerator, and divide it by 27. So I get 0.370 repeating, and notice that 37 is bigger than 34, so this would not be an answer. D, take 7 and divide it by 20 on your calculator, and you get 35. Once again, 35 is bigger than 34, so that's not an answer. And finally, 17 over 50. 17 over 50 is 35. In this case, they're equal. Now notice here, up here in our question, it says are less than or equal, or sign like that. So this would be equal, so that would have been included as an answer for this one. So the answer for 6 is B and E. Problem number 7 states that a plane is flying at 33,540 feet. To avoid turbulence, the plane ascends 1,725 feet. It then descends 3/5 of its new height to prepare for landing. What is the height that the plane will be after it ascends to avoid turbulence, and what is its height after it descends to prepare for landing? So first of all, we need to understand the words. To ascend or ascent means to go up. That means we're going to add. So we start with 33,540 and we start here and we're going to add 1,725. So that means when we add it, we get 35,265, and that's the height after the ascent. To descend or descent means to go down, so we subtract. The amount we subtract is a fraction times our altitude. We're going to descend 3/5. So that means we need to find out what is 3/5, what is the fraction of our height. So we take 3/5 and multiply it by 35,265. I noticed that 5 goes into this 7,053 times. And so now I just need to multiply 3 times 7053, and I find out that the altitude we descend to is 21,000. We descend by 3/5. So this is how much we're going down. So when I take my amount after ascent and go down 21,159, we'll end up at 14,106 feet, and that's the answer to B. In problem 8, Rashad purchased movie tickets for himself and 2 friends. After buying the tickets, he had $14 left over to buy snacks for the movie. The following box shows the prices including tax. Candy's $1.25, popcorn's $3, and the drinks are $2.75. What we want to find out is which A, B, and C, and D, which ones could he afford with $14? So what we need to do is find out how much each answer costs and see if it's less than or equal to $14. So the first one, we have 2 drinks, so 2 times $2.75, and 3 popcorns, and the popcorns are $3, so 3 times 3. So that is $5.50 plus 9, which is $14.50. Close, but it's too much. It's greater than 14, so A is not a possible answer. B is 3 popcorns, or 3 times $3, and 1 candy, 1 times $1.25. So that's 9 plus $1.25. So that's equal to $10.25, and that is below 14. So that's a possible snacks that he could buy for his friends. C, he orders another popcorn. So 4 popcorns, 4 times 3 plus $1.25, $12 plus $1.25, or $13.25. So once again, it's below 14. So he can order that, and C is a possible answer. Finally, we have 4 drinks and 2 popcorns. Well, 4 drinks, each drink is $2.75 plus 2 times $3, so we have $11 plus $6. Well, that's $17, and that's much more than 14. So D would not be a possible answer. And so the answers for 8 are B and C. In problem 9, Keon is calculating his expenses from his work trip to San Francisco. Below is the log he kept. On the airplane, he paid $349 for a round-trip ticket and $12 for a movie. His hotel was $130 per night, and he stayed there 3 nights. His dinner was $53, and he left an $11 tip. He gets mileage for his car, which at 50 cents per mile, and he traveled 71 miles. He's going to submit all of his expenses to his company for reimbursement except for the movie. So how much will he be reimbursed for? Well, first of all, his movie was $349, but it included the $12. So since he is not going to have the company pay for the $12, he will subtract the $12 first, and that's going to be $337 that he reports to his work. The hotel, $135 for 3 nights, so $135 times 3 is going to be $405 for his hotel. His dinner is $53 plus the tip, so that the plus means we're going to add here. So 53, just like up here, per night means we're going to multiply by 3. So this is going to be 53 plus 11, or $64. And then finally 50 cents per mile, and you see we're going to multiply the miles times the rate that we get. So 55 times 71 is 3905. So when we add these all up, our answer should be $845.05. Problem 10 asks us this question: which expression is equivalent to negative 17 minus 30? Well, the key to this problem is to understand subtraction. Subtraction is the same as adding the opposite. In other words, 5 minus 3 is the same as 5. 5 minus 3 is the same as 5 plus, adding, and the opposite of 3 is minus 3. So in this case, we're taking minus 17 minus 30, so we're going to change that to adding. So we're going to change this to add, and the opposite of 30 is minus 30. In other words, minus 17 plus minus 30. And if we look up above, we can see that that is answer D. Okay. if you actually work these out, minus 30 plus 17 actually works out to be plus 13. Likewise here, 17 plus 30 would be 47, and 17 plus minus 30 would be negative 13. Whereas this one, we're adding two negative numbers together and we would get minus 47. And that's what we would have here if we work this out on the number line. So the answer in this case is D. Problem 11 asks us to simplify a fraction problem. We have negative 3/5 subtract 3/10. Well, the first thing we want to do is get common denominators. So I'm going to look at the multiples of 5 and 10 and find the smallest number that they both share. So 5, 5, 10, 15, 20, and 10, 10, 20, 30. The smallest one is 10. 5 goes into 10 and 10 goes into 10. So all we need to do is change 3/5, multiply that by 2, and notice I'm going to get the 2 times the 5 will give me a 10. But I also, again, have to multiply by a variation of 1, so I'm not changing the number. The other thing you'll notice that I did is I changed subtraction to adding the opposite. So this became plus minus 3. Okay? So let's do that multiplication there. And we get minus 6/10 plus minus 3/10. So when we go to add the numerators, we have negative 6 plus negative 3, or negative 9/10. And that's our answer, negative 9/10. In problem 12, there's a little bit of a typo in the problem. It says, Felix writes the math problem negative 5 times the quantity negative 3 plus a negative 7. And then it asks what's the value of n. Obviously what it's after is what is this value equal to? Now the first thing we notice here is if I set that up, I'm going to see that the opposite of a negative number is a positive number. So I'm adding the opposite of negative 7. Well, the opposite of negative 7, if you think about this, if I have a number line and here's 0 and here's negative 7 and I say where's the opposite? Well, the opposite's on the opposite side at positive 7. So the opposite of opposite 7 is positive 7. So we have negative 5 times the quantity negative 3 plus 7. Now negative 3 and 7, we do the parentheses first. Negative 3 and 7 is going to be positive 4. Same sign add and keep, different sign subtract. 7 minus 3 is 4. Take the sign of the higher number. The bigger number is 7, so it's positive 4. Or if you did the T-chart, plus and minus, you would have put 3 here, 7 here. The smaller number comes over, and you would end up with 4 in the positive number. So that's 4. Now finally, we have negative 5 times positive 4. And we remember that a positive times a negative is a negative. Remember, if we have a 49er meets a Raider, we're likely to get a fight. A positive times a negative gives us a negative. So the answer will be negative 20. Problem 13 asks us this question. The gas tank in Mr. Mackey's car holds 14 2/5 gallons of gasoline. How many gallons of gasoline are in the tank when it is 1/4 full? Well, to find 1/4 of something, we can either multiply by 1/4 or divide by 4. So in this case, let's multiply 1/4 times 14 2/5. Now we can't multiply a fraction times a mixed number, so we have to change this mixed number to an improper fraction. So we're going to multiply 15 times 4 and add 2. And so we end up with 72 over 5. And now we can multiply 1 times 72 and then 4 times 5. Or sometimes if we see where we can divide something out ahead of time, I notice that 4 goes into 72, 18. Now I just have to multiply 1 times 18 and 1 times 5. And so our answer is 18 over 5. Well, let's change that back to a mixed number. So we change that, and 5 goes into 18 3 times, and then that'll be 3 times 5 will be 15. And you see you'd have a remainder of 3. So that means our answer is actually 3, with a remainder of 3/5 gallons. And that's the answer, 3 3/5 gallons. Problem 14 states that a bottle contains 4/5 of a gallon of fruit punch. If 8 people share the fruit punch equally, how much fruit punch does each person get? Well, if 8 people are going to share the 4/5 of a gallon, then we're going to divide the 4/5 by 8. If you split something between 8 people, you divide it into 8 sections. So we're going to take 4/5 and divide it by 8. Now when we divide fractions, we usually don't divide it by a whole number, so we're going to change the whole number to a fraction. 8 is the same as 8/1. At this point, when we go to divide a fraction, we need to remember that division is the same as multiplying by the reciprocal. So I'm going to change this to multiply, and the reciprocal of 8/1 is 1/8. Now you may have learned this in elementary school with the old KFC, keep, flip, change, which means I keep this, I flip this, and I change my sign. I keep the 4/5, I flip, that's my reciprocal, and I change it from division to multiplication. Either way you want to remember it, but I encourage you to remember that division is the same as multiplying by the reciprocal. Okay? And then our next step is just to multiply across. 4 times 1 is 4. Actually, I took out the 4 into that and got 2. So on top we have, let me just clear that up so you see it. 4 goes into 8 2 times, so 1 and 2. 1 times 1 is 1 over 5 times 2, and that's 1/10 of a gallon. So each person will get 1/10 of a gallon. By the way, if you wanted to check your answer, you could just take it and go, okay, what's 8 times 1/10? If each person gets 1, change that to 8/1. 8 times 1 is 8. 1 times 10, 8/10. Notice I can reduce this by dividing both by 2, and I end up with 4/5, which is what we started with. So I know I got the right answer. Problem 15 states that Wendy stood on a number line and threw the ball. Here's Wendy. She throws the ball 7 feet to Anna, to the left of her friend Anna. Anna then throws the ball over her head, and it goes 4 feet past. So she goes 7 this way, throws it back, and it goes 4 past there. The question is, how far did Anna throw the ball? Well, obviously Anna threw the ball from here to here, okay? From -6 to +4 on the line. The question is, how far is that? How far is it from here to here? Well, to find distance, distance is the absolute value of the difference between 2 points. And the reason I say that between 2 points, because when you're using absolute value, you can actually go either direction. I can either write that 4, the absolute value of 4 minus -6 is one way, or I could say -6 minus 4 that way, and again, we're taking the absolute value. You never say it's -5 miles to something. It can be 5 miles one way and 7 miles another, but distance is always positive. So the first one, 4 subtract a -6. Remember that subtraction is adding the opposite. So I can change this to adding, and the opposite of -6 is 6. So we end up with 4 plus 6, or the absolute value of 10, which is 10 feet. On the other hand, if you subtracted the other direction, -6 minus 4, on the number line, if you're out at -6 and you go 4 more, 7, 8, 9, 10, you end up with the absolute value of -10. Or in this case, I changed subtraction to adding the opposite. So -6 and -4 add to -10. But the absolute value of -10, how far is -10 from 0, is 10 again. And that's the answer either way that you work it. If you really forgot and you couldn't remember any of that, just count. Start here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. She threw it 10 feet. 16 is a similar problem regarding distance. It says that a mine shaft starts at 189 feet, negative 189, meaning the distance below the ground, and ends at negative 127, 127 feet below. And they want to know which of these expressions could be used to determine the vertical distance between the starting and ending points in the mine shaft. Now, if I draw a number line vertically like that, thinking that I'm going underground, notice it starts 189 feet below surface and then moves up to 127. And we want to find out what's the distance there. Remember again that distance is the absolute value of the difference between 2 points. So I can write this either way. I can write that it's minus 127 minus 189 absolute value, or I can say it's 189 minus a negative 127 that direction. Either one of these two expressions here are appropriate. They'll give us the same answer. And notice, first of all, when I have a minus, I can change that subtraction to adding the opposite. So when I change it to adding the opposite, you see I change the minus to add, and the opposite of 189 becomes plus. So we end up just adding those. So negative 127 plus 189 is 62, and the absolute value of that is 62 feet. The second one, again, I can take the minus and change it to the adding the opposite. So notice that I change subtracting becomes adding, and the opposite of negative is positive. So we end up with just plus 187. In this case, we end up with negative 62, but we're looking at the absolute value, and so the answer there is 62 feet. Now the question is, which of these expression works? Well, notice this one is here, and that applies to number letter D. If you notice here, these other answers don't work. Negative 187 plus 127 will give you negative 62 feet, and we never express distance as a negative. This one's even worse because you really end up with a negative, and you end up with, let's see, 7 and 9 is 16, carry the 1, 11, negative 316 feet, nowhere close. And similarly here, this ends up being the absolute value of negative 316, which equals positive 316 feet. So none of these work at all. Only that one. This one would work as well, but it wasn't listed. Problem 17 says that Timothy runs a catering service for large parties. He needs 27 heads of lettuce for salad to feed 100 guests. So we've got 27 heads here, and we got 100 guests. Which of the following ratios illustrated how many heads of lettuce X would he need to feed 225 people? So that's essentially the numbers that we're looking at here for this one. First thing we want to do is set up our ratio. So we're going to set up and compare the heads of lettuce to the number of guests. You could turn this upside down and compare the number of guests to the heads of lettuce, and it would work out exactly the same. But I'm choosing this one somewhat because I can look over here, and I can look over here and go, oh, look, the hundreds in the bottom. So they must have the guests on the bottom. So that's another reason for us to set it up in this fashion. And so now we're going to set up the proportion this way. And so first off, let's talk about what they have now. How many heads of lettuce do they have? Well, they have 27 heads, so I'll put 27 in my first ratio, 27 heads, and that 27 heads was for 100 guests, so it's 27 to 100. That's the ratio that we know. Now in the next one, the heads of lettuce is, the number we're going to try to feed is 225, so that's the number of guests, 225, and how many do we need is what we're looking for, X. Now we have our proportion. And now all we need to do is set it up. And you notice here we're not even asked to solve it. We're just asked to see which one matches that. And the answer is B. In number 18, we're asked which table shows a proportional relationship. To be a proportional relationship, the y to the x has to be some constant. In other words, no matter which x or y you take, when you divide them, they should always equal the same number. So let's start with A. First of all, the first row, 15 divided by 3 is 5. So 20 divided by 3 is 5. So far they're the same. 25 divided by 5 is 5. 35 divided by 6, however, is 5.83. And 40 divided by 5 is different. So notice that the ratio is not the same. So A is not a proportion. Let's try B. 24 divided by 3, the first row, 8. 32 divided by 4 is 8. 45 divided by 5 is 9. So notice at this point, and we now know it's not. Let me just finish them out. And all of them are 8 except for the 5 to 45. But since one is not, this is not a proportional relationship. C, 21 divided by 3 is 7. 24 divided by 4 is 6. Again, we now have two different numbers, so this is not a proportion. Let's just check the rest. 35 divided by 5 is 7, 7, and 7. So 1 didn't work here, so that is not a proportion. So hopefully D is our proportion. 12 divided by 3 is 4. 16 divided by 4 is 4. 20 divided by 5 is 5. 24 divided by 6 is 4. And 28, they're all the same. So that is our proportional relationship, and the answer is D. In problem 19, they give us a graph below, and it represents the relationship between the number of hours that Jamie works here and the amount of money that she earns here. So it's work versus hours. Which of the following statements describe the graph? So we just got to look at each graph and find which one is true. This one says that number A says the total money earned for babysitting 4 hours is $20. So notice if I go to 4 hours and I come up and then I go over, yep, it's 20 hours. So that's true. So I'll circle that one as being true. Okay. B says that point A, right here, represents the money earned for 2 hours. So if I go to A and drop down, yeah, that's 2 hours. So that one is true as well. Point C says that point A represents the money earned for each hour. Well, point A can't be each hour and 2 hours, so this one obviously can't be true. And so C is not an answer. In D, Jane earns $1 for every 5 hours she babysits. So if I come over here to 1 hour, or here's 5 hours, 5 hours, notice, means that she's earned $25. So that's not $1, she earned $25, so that's not true. And finally, Jane earns $5 for every hour she babysits. Okay, so let's come over here and check that out. 1 hour she works, she earns $5. That's true. So A, B, and E are correct answers for number 19. Number 20 asks us which graph represents a proportional relationship between X and Y. Key thing to remember on a graph is, and the graph is of a proportional relationship, is 1, it's always a straight line, and 2, it goes through an origin. So those two things must be true. It has to be a straight line, and it has to pass through the origin 0, 0. So we look at the first one. The first one is not a straight line. If you look at that, it's curved, so that's not a proportion. The second one is a straight line, but it doesn't go through the origin. So that is not a proportion. The third one is a straight line, and it goes to the origin, so there's our answer. It's a proportion. The last one is also a straight line, but it does not go through the origin, so it is not a proportion. So the answer there is C. 21 states, which proportional relationship has a unit rate of 4.5? First thing we realize is that a unit rate of proportional relationships, we take the y and divide it by the x, and it'll be a constant, as we saw in an earlier problem. We want to find which one is the ratio of y to x 4.5. So we start with A. We take the first line, 5 divided by 2 is 2.5, so that is not 4.5. Okay, so that one doesn't work. B, 9 divided by 2 is 4.5, so that answer does have a unit rate of 4.5. Check the other ones. 7 divided by 2 is 3.5, not our answer. and 6 divided by 2 is 3, not our answer. So the correct answer, the one with a unit rate of 4.5, is B. Problem 22 says that 45% of the 860 students at Julian's school are male. How many male students are in Julian's school? So let's set up our proportion. One equation we have is that the part is equal to the percentage times the whole when we write the percentage as a number over 100. In this case then, first of all, we know that there are 860 students. I always tell students, when you see the of the 860, that's your whole. The whole number usually goes with the of. So it's of 860. And then 45%, since we're writing it over 100, we'll drop the percent and put it as 45. 45 over 100, the percent sign means, I always tell my students this, percent means divide by 100. Okay? So 45% means 45 over 100. And so now we can just solve that. So 45 over 100, 45 times 860 divided by 100, and our answer is 387 is the answer. Now another way you can do it is, instead of doing this as a fraction, you can just use the percentage, but change the percent. 45% equals 0.45. It also equals, as we saw, all three of those are the same thing: 45%, 45 hundredths, and 45 hundredths is a fraction. So you can use it this way. This way is very helpful when you're using a calculator, because you for 45% you put 0.45, multiply it by 860, and you get that the answer is 387, just like the other way. So the answer is 387. There are 387 male students at Julian's school. Problem 23 is a sales problem. Walt is buying a bicycle that regularly costs $170. It's on sale for 25% off. That means we're going to subtract 25% to find out what we're going to pay for it. But then we have a tax rate of 6%, and the store always adds the 6% on afterwards. So we start at 160, we're going to subtract 25%, and we're going to add 6%. All right? So let's get started. So we have a couple of steps in this one. So first we're going to find out what's the discount. How much are we taking off? Well, the discount is 25%, and we're going to use the part is equal to percent times the whole. So my discount here is 25%, and notice I'm using 25% as 25 hundredths times 170. So the discount is $42.50. That's how much we get to take off of the price. So we're going to subtract the discount from the regular price. So the sale price is the regular price minus the discount. So 170 where we started minus 42.50 means that our sale price is 127.50. So that's how much they're selling the bike for now. So now we just got to figure out the tax and add to it. By the way, there is an alternate method. I could have just subtracted the 25% from 100% to begin with, and said that instead of getting 25% off, I'm buying the bike at 75% of its value. But I would get the same answer doing that way as well. Okay? So let's start work on the tax now. The sale price we decided was $127.50. Now let's find the sales tax. Well, again, part equals percent times whole, so the tax is 6% times 127.50. So we get 6 times that, so my tax is $7.65. So to find out what I actually have to pay the store, now we will add the sales tax to the price. So we add $125.50 to $7.65, and our final answer is the bike is going to cost us $135.15. So notice that we found the discount and subtracted it to find the sale price, and then we found the tax on the sale price and added it to that to find what we actually had to pay. Final cost, $135.15. Problem 24 says that the Singh family takes a road trip every year. This year, the family recorded the total distance traveled after each hour and plotted the points on the graph below. What is the speed at which they traveled? Notice here that each of these is per hour. So if you can figure out how many kilometers they travel in 1 hour, you'll know the answer. So if we come down to our graph and come down here to 1 hour, notice that 1 hour, if I go up there and over there, 1 hour equals halfway between 0 and 150. So they're traveling 50 miles per hour, or the answer is B, 50 miles per hour. Problem 25. Brian's comic book collection increased from 150 books to 195. By what percentage did his collection increase? All right. So first question, did it go up or down? And the answer is, since the collection went up from 150 to 195, obviously this is an increase. So we're looking for a percentage increase. So step one, let's find out how much it went up. Well, 195 minus 150, it went up 45 comic books. So we're going to find the percent of increase. And to do that, we always find how much did it increase divided by where did it start, the original amount. Always where it started, not where it ended up. So the amount of increase was 45. Where it started was 150. Be careful here. One problem students sometimes make is they'll, instead of 150, they'll put in where it ended up 195, and that's different. The increase is from where you started. So 45 divided by 50, and that equals 0.30. So remember that what percent of that is. If I move that over twice, I get that that's 30%. So the percent of increase was 30%. Problem 26 says that Kevin works at a paint store and is paid a 9% commission on his sales. In other words, instead of getting paid by the hour, he gets paid a percentage of everything he sells to other customers. This is to induce him to work real hard. Today his sales total was $850, so he gets 9% of $850. So how much did he earn? We're looking for 9% of $850. Remember that part equals the percent times the whole. So in this case, my whole was $850. That's what he made. So the 850 is my whole. And then the percent is 9%. And I'm going to change that to 900ths. So 9% or 900ths. And now we can find out what his commission was. So 9 times 850 divided by 100. And we find out that the answer is his commission was $76.50. Now they asked us to round it, though, to the nearest dollar. So we'll go to the nearest dollar. We look next door, and there's a 5. Remember, if it's 5 or bigger, we round up. If it's lower than 5, we round down. So 5 is equal in the middle, so we round up to $77. So to the nearest dollar, Kevin earned about $77 today. Problem 27 says that a store sells CDs for $15 each. In the proportional relationship between X, which is the total number of CDs they purchased, and Y, which is the total cost they paid for the CDs, the constant of proportionality is 15. They want to know which of these equations, A, B, C, or D, represent that relationship between X and Y. First of all, when we're talking about a constant of proportionality, we mean that the relationship between Y to X, that ratio, equals some constant K. K is our proportional constant of proportionality. So we can substitute 15 in there, and this is my equation. So as we look over here, we see there is one D that's set up similar to that, but it's not exactly that. Y equals 15 over X. Maybe, but maybe not. These others are set up with solve for Y. So let's solve ours for Y and see if we find our answer. To undo divide by X, we multiply by X. So I multiply both sides by X, then X divided by X is 1. so I'm left with y equals 15x. Now when I look at my answers, I see that the answer is C. In problem 28, it says that Daniel bought a computer game for $35 and later sold it to Thomas for a 40% profit. How much did he sell the computer game for? So what we're going to find is, first of all, we're going to find out what's 40% of 35, the profit, and then we're going to add it to the 35 to find out how much he actually sold it for. So let's begin. First, we're going to find the profit. To find the profit, it is 40% of 35, so part equals percent times whole, so that's going to be 40% or 40 hundredths times $35, and so his profit is $14. So that's how much he made when he sold it for a higher amount. So to find what he sold it for, we're going to add the profit to the original price. So the new price is the original price plus the profit. So at this point was 35 plus 14, and our answer is he sold this for $49. $49, he made $14 or 40% on his original investment. 29 is an interest problem. It says that Bonnie borrowed $3,500 from the bank, and each year the bank charges her 6% simple interest. How much interest will be owed in 1 year, so there's our time, if no payments are to be made? So in this case, we're going to find the interest using our interest formula. The interest formula says that interest equals PRT, the principal, the rate, and the time. So as we look up above here, I'm going to put up here that, first of all, our principal is $3,500, so that goes in the first slot, principal P. Our rate is 6%. Now remember, that's 6/100ths. So it's 0.06. Don't put 0.6. That would be 60%. This is 600ths. And then how much time? She was only using it for 1 year, so we're going to put 1 for T. So our interest would be that. So we simply calculate that together, and we find out that the interest is $210. And that's our answer. Putting $3,500 in her bank at 6%, at the end of the year, the bank will give her another $210 to add to her account. Now, problem 30 is an interesting question. It's a discount problem, a sales price. Which of the following situations results in a sale price that is less than or equal to, that means less than or equal to $50? Select two that apply. So they're telling us that two of these work. Now, when we do a problem like that, there's two ways to do it. First, we could multiply 35% times $69.99, and that would be our discount, and then we would subtract that from $69.99. Another way we can do it, though, is to subtract the discount 35% from 100% and then multiply it to find what we're paying for it. Now, they both ways work. The second way sometimes is easier because it doesn't require as much math. So, for example, in the first one, if I'm getting 35% off, that means I'm paying 65% of the cost. So now I just have to do 65% or 65 hundredths times $69.99. That's 45.4935. If we round off to the nearest penny, I go to next door, there's a 3, that's less than 5, so we don't round up, we leave it at 45.49, and that is less than $50. So A would be something that we could afford. For B, notice that the rate is 45%. Well, if I get 45% off, 100% minus 45 means that I'm paying 55%. So 55 times $91.99, that's the price they're selling it for, is going to be 50.59. If I round off the nearest penny, there's a 4, so it's less than 5, so we don't round off, so it's 50.59, but that is greater than $50, so B would not be acceptable. C, our percent off is 60% off. Well, if I get 60% off, then what I'm paying is 40%, 100 minus 60. So 40% of $89.99 is $35.996. If I round off to the nearest penny, I look next door and there's a 6, bigger than 5, so we're going to round up. be careful in this one, because when I add a penny to the 9, it's going to cause it to go to 10 and carry 1 and carry 1, and it actually ends up to be $36. But that is less than $50, so that is an acceptable answer. Finally, D, we get 40% off. 100% minus 40% is 60%. So we're paying 60% of $99.95, $99.99. That's $59,994. If we round off the nearest cent, next to the right is a 4. That's less than 5, so we don't add. So that's $59.99, and that's greater than 50. So that one is not an acceptable answer. So the answer for 30 is A and C. I hope you enjoyed this. I hope it's helpful. I hope you do really well in the test. Have a good day.